Now let's talk about the second strategy of case splits, the one that aren't your fault. Sometimes the split in your code are forced by your third party APIs or external dependencies. Now this can be particularly frustrating because you're dealing with complexity you didn't create and you can't control. This is where the adapter pattern, also known as the anti-corruption layer, is your solution. The key insight is that you shouldn't let external complexity leak into your application logic. Let's take a concrete example to understand this better. Imagine you're working with an HTTP client library for saving data to a remote service. Here's what it might look like. In your save page method, you start by calling http client.post to send the page data. Then you need to check the response status code. If it's 200, that's success. But what if the response is malformed? If it's 429, you're being rate limited. So you need to retry with backoff. But how long should you wait? If it's 503, the service is unavailable. So you need a fallback. But which fallback? Then you need exceptional handling. If you get a connect exception, there's a network error. So you should retry. But how many times? If you get a timeout exception, you might want to use the fallback. But should you retry first? Look at what's happened here. Your page service, which should be focused on page management business logic, has become an expert in HTTP status codes, retry algorithms, and network error handling. This is external complexity leaking into your domain logic. The solution is to create an adapter that handles all this complexity and presents a clean interface to your service. First, we define a clean interface that hides the complexity. A page gateway interface has just one method, save a page data object, and it might throw a page save exception. Then we implement a resilient page gateway that handles all the HTTP complexity. In its constructor, it takes the HTTP client, fallback storage, and sets up a retry policy with 3 retries and exponential backoff from 1 to 10 seconds. The save method wraps everything in the retry policy. It makes the HTTP call, and if the status is 200, it returns successfully. If it's 503, it saves to a fallback storage. For other errors, it throws a retriable exception that triggers the retry mechanism. If all retries fail, it falls back to the backup storage. Now look what happens to the page service. It becomes simple again. The constructor takes a page gateway and the save page method just calls gateway.save data. All the complexity is hidden. The page service has become simple again. It's focused on page management, not HTTP protocols. All the complexity is encapsulated in the adapter where it belongs. And here's the good part. You can test the page service without worrying about HTTP timeouts or retry logic. You can test the adapter separately to make sure it handles all the edge cases correctly. Another powerful technique for dependency induced splits is capability interfaces. The problem with many APIs is that they force you to check what kind of implementation you're working with and then branch accordingly. Here's a common example with a notification system. You have a send notification method that takes a message and a notification channel. Then you have to check what type of channel it is. If it's an email channel, you cast it and check if HTML is supported. If it is, you format it as HTML and send it. If not, you send plain text. If it's an SMS channel, you check the message length and truncate it if it's over 160 characters. If it's a push channel, you send with high priority. Now, this is ugly for several reasons. Your notification service has to know about the specific capabilities of each channel type. It has to know that SMS has a 160 character limit, that email might not support HTML, that push notifications need priority levels. Every time you add a new channel type, you have to modify this method. The solution is to design your interfaces around capabilities, not implementations. We create a notification channel interface that defines capabilities. Send a message, get the maximum length, and check if rich content is supported. Now, each implementation would handle its own constraint. The email channel send method checks if it supports rich content, and if so, formats as HTML. Otherwise, it sends plain text. It reports no length limits that it supports rich content. The SMS channel send method checks if the method is longer than its maximum length and truncates if necessary. It reports a 160 character limit and that it doesn't support rich content. And your notification service becomes incredibly simple. Just one line call that calls channel.send message, no conditionals, no type checking, no knowledge of specific channel limitations. The service is now completely implementation agnostic.